Hey everyone, I'm going to be telling you about black holes today. So normal black holes, the stellar black holes that we already know about, and the supermassive black holes as well, okay? So stellar black holes, do go on the video where I say something about black holes, is in a playlist called Classification of Stars. So the stellar black holes come from a death of a very massive star. So when a massive star dies, what happens is that star runs out of fuel, or actually instead of running out of fuel is what is happening is at the center of that star, the star is going to make nuclear fusion reactions, and it will keep building to heavier and heavier elements until it gets to iron. When it gets to iron, so when it builds up to a heavier element, and that heavier element is iron, the reactions, nuclear fusion reactions, they don't give out heat, instead they take heat. That means that the star stops having enough heat that can act as and can form pressure to counterbalance the force of gravity of the own star. So the own star is going to fall onto itself, collapse onto itself into a supernova, type 2 supernova, okay? And then when this happens, this is going to be stars of about 20-25 times the sun, the mass of the sun. Sometimes even with 8 you could have a black hole, and at the center you get a black hole. So the star completely collapses, becomes flat, and is not even light can escape because it's external, extremely, oh, here we go, extremely dense, or infinitely dense, so not even light can get out. So that's what we call black holes, okay? Then we have supermassive black holes. Now these ones are a little bit more mysterious because we don't quite know yet what they are, how they were formed, but we believe they are found at the center of galaxies, okay? And they have many million times the mass of our sun. And if we would think about the normal black hole, they will have between 1 million and 1 billion times the mass of a typical stellar black hole, okay? It's enormous. And do go on this video, which I'm going to put on the link, on the description, sorry. So go on the link, which I'm going to put on the description. It will go to a video that everyone gets stunned by seeing. You will be blown away because you're going to see a very supermassive black hole and how many million times the mass of the sun will have, okay? So do that. Now, formation of quasars from supernova black holes. A supernova, oh my god. Supermassive black holes. So supermassive black holes, they are likely to be present in the center of all or most of large galaxies, and although this is still being studied, it looks like there is a link between the size of the galaxy and the size of the black hole. So larger galaxies, they do have larger black holes, okay? So there must be a link between the formation of the galaxy and its black hole, or vice versa, but this is still on research at the moment, okay? Now, scientists believe, most of them, that the supermassive black holes, they are the center of this, the galaxies. They are the engines that power the quasars. And do go on the video on the quasars, the previous video, if you want to know more about quasars, okay? Now, quasars, radio galaxies, they probably are going to be more or less the same thing, okay? It's going to be all a black hole with energetic beams, jets beaming out from the two sides, so lots of all of the types of the electromagnetic radiation going from the jets, okay, perpendicular to the disk. But if the beam is directed towards us, we see it as a quasar because we kind of get the light like a lighthouse. But if the beam is in a different orientation, then we just believe that is an active galaxy or a radio galaxy. And it's a radio galaxy because most of the electromagnetic radiation that we receive, although we get from all types of electromagnetic spectrum, so all wavelengths, they are very, very powerful radio sources, okay? So we could be even talking about the same thing, but we don't know yet, okay? So all that we know at the moment is from research, and I'll tell you how the research went and is here on this slide, so you can always pause it. But all that we know is from research, okay? So the things that I'm telling you right now, they can change. So it doesn't mean, it's not like other fields of astrophysics where I'll tell you something and I say that's exactly how it is. This one is pretty much still happening at the moment, and we are still learning what the things are, okay? So the astronomers only had an indirect evidence for massive black holes, okay, because they could see, for example, that there was an existence of quasars in some active galaxies, okay? And then when they look at the output energy, they saw that the energy that was being given out was over 1 trillion times as much as the energy of our sun, okay? And the region where this energy was being given out, it was a region very small in terms of the size of the universe. It was a region about the size of the solar system. So the only thing that we know of that is capable of doing such thing is a black hole, a massive black hole, because this thing is picking up gravitational energy and turning it into light, okay? So we only know that black holes do this, so we decided to call them more massive black holes, supermassive black holes, because they are just like black holes, but they have many billion more times the mass. If you already saw the video, you already know what I'm talking about, okay? So if you cannot see them directly, you need to find a way, okay? So what they did was checking the material that was around the center of galaxies. So if you cannot see the black hole itself, because not even light can escape, you may look for the behavior of the things around the black hole, so stars and gas, okay? As I said in lesson, it's like if you have a sink full of water and you are in a dark room and you want to study if there is a plug really at the center of the sink. But if you are in the dark room and you cannot touch it, you don't quite know. But on the other hand, if you put fluorescent powder into the light, into the water, and then you will see the fluorescent powder going around the plug and going faster and faster and being sucked in, you will get some evidence that maybe there is a plug there. The same with the black holes. So instead of trying to look for a black hole, they decided to look for the behavior of the material at the center of the galaxy, so around the black hole, okay? So the orbital velocities, they were quite high, and they could only be explained if you would have an acceleration by a massive object with a very strong gravitational field. So this is again the characteristics of a black hole, and because this was quite big, they call it a supermassive black hole, okay? Now, astronomers do not know how supermassive black holes form. We know that stellar black holes form from the collapse of a very massive star, but we don't know about the supermassive black holes, okay? So there are 3 different theories about how they can form. So it could be the collapse of massive clouds of gas during the early stages of the formation of a galaxy. It could be a stellar black hole that consumes a lot of energy and a lot of, material over millions of years, and then it grows into a supermassive black hole. Or then it could be a cluster of stellar, small, let's say, black holes that form and eventually merge into a supermassive black hole, okay? Now, whatever the formation is, most of the astronomers, they do agree that the accretion of the material onto the supermassive black hole drives the active galactic nuclei, okay, and the galactic jets. So we don't quite know what they are yet. We know that they are related to the size of the galaxies and to quasars, but that's what we have at the moment, okay? Now, there is some direct evidence that was seen later on, and this is what you see here in the picture. So this was by looking at the stars around Sagittarius A, where we believe there is going to be a supermassive black hole of about 3 million solar masses, okay? So this is right at the center of our Milky Way, and what they did was, instead of looking for the black hole itself, they were measuring the velocities of the stars around the black hole, okay? And they did the measurements. This is a picture taken in 2002, and you can see that from the measurements, they could see that the objects were orbiting around something, and that something had to be quite massive, and they were orbiting around quite fast, okay? So this is so far the best evidence that we have that they may be or that they are these supermassive black holes. So that's all for black holes. I will then do something about redshift and the expansion of the universe, but that's going to be a different video. So that's all for today, and I'll see you next time. Bye!